We are looking at transformations today, and a transformation is a change in the position, size, or shape of a figure. So the first transformation that we are going to talk about is a translation, and another word for translation is slide. And this type of transformation that moves each point in a figure the same distance in the same direction. So we're going to slide it left, right, up, or down, or a few of those together. So for example 1, perform the given transformation on the point 2, -1 that's already plotted for you, and give the coordinates of the translated point. So we are going to, for part A, have to slide it 4 units left. So if I go to the point 2, -1 there, it's a red dot, we're going to move it 4 units to the left. So I'm just going to count 1, 2, 3, 4, and that is where it will end. That is moving it 4 units to the left. And then for part B, we have to move it 2 units right and then 3 units up. So I'm going to start where the red dot is at 2, -1, and I'm going to go 2 units to the right, so 1, 2, and then I'm going to have to slide up 3. So 1, 2, 3. And that's the new point. So for both of these questions, it said to do the transformation and then give the new ordered pair the new coordinates. So for part A, it looks like we're over -2 and we are down 1. And then for part B, we are over 4 and up 2. So I want you to notice that when we translated left or right, that just the x coordinate changed, and that when we slid up or down, that's when the y coordinate changed. So with that being said, right here, a horizontal translation, which is right or left, the x coordinate changes. So we add whatever slide it is to the x value. So if we're going to slide 4 units to the right, we're going to add 4 to the x. If we're going to slide 4 units to the left, then we're going to add a -4 to that x value. And vertical translations work the same way, except for the y coordinate is changing. So if we're going to slide up, we're just going to add a number. Let's say we're moving 3 units up, so we'd add 3 to the y coordinate. If we're going to slide down 3, then we would add a -3 or subtract 3 from our y coordinate. The next transformation is a reflection, which is like a mirror. It flips the figure across the line that is called the line of reflection. So if we reflect across the y-axis, the x-coordinate is going to change, and all the change is that it becomes opposite. So if it's a +2, it's now going to be a -2 once we reflect it across the y-axis. If it's a reflection across the x-axis, then our y-coordinate changes, and it becomes opposite. So for example 2, it says use a table to perform each transformation of y equals f of x. Use the same coordinate plane as the original function. So we have this graph given here, and we have to make a table before we can translate it 2 units down. So I'm going to write some points down that we already know. So I can see that point there is -2 and up 1. This point here is over 0 and up 1. And another point would be down here, which looks like 1, 2, 3 over 3 and down 2. And this one here is over 5 and up 0, and then over 6 and up 1. So I just picked some points off of that graph. And we have to use the rule. If we're going to translate it 2 units down, if we go back up here, it looks like we're going to change the vertical translation says that we have to add or subtract to the y value. So if we're going 2 units down, we're going to subtract 2 from the y value. So now I'm going to add a third column on here. And 1 minus 2 would give us a -1. Another 1 minus 2 would give us negative 1. Negative 2 minus 2 would give us negative 4. 0 minus 2 would give us a negative 2, and 1 minus 2 would give us a negative 1. So now I'm going to plot, I'm going to leave the x's the same, but I'm going to plot these points with our new y value. So negative 2, negative 1. So negative 2, negative 1 is right here. And 0, negative 1 over 0 and down 1 is there. 3, negative 4, so over 3 and down 4 is there. 5, negative 2 would be here. And 6, negative 1 would be here. And then we can go ahead and connect those dots and see that the graph is just shifted down 2 units from each point on the original. All right, for this one, again, we have to use a table, and then we have to reflect it across the y-axis. So if I write a t-chart, we're going to have to pick some points off that graph. It looks like over 0, up 4, over 1, up 2, 2, 0, 3, negative 2, and we'll do 4, 0. And if I go back to the rule, the reflection across the y-axis right here says that my x coordinate changes, and looking right here, the x value just becomes opposite. So we're going to make a new column over here for a new x value, and we make our x's all opposite. So 0 is just going to be 0. 1 will be negative 1. 2 would be negative 2. 3 would be negative 3, and 4 would be negative 4. And then we're going to plot those points, those new points on our graph over here. So 0, 4 over 0, up 4 is not going to change. Then we're going to have negative 1 and up 2, and negative 2 and up 0, negative 3 and negative 2, and then negative 4, 0. So if I go back and connect those, you can see that it flips over the y-axis. Now, for stretches and compressions, stretches are pulling points away from the y-axis, and a compression, a horizontal compression, would be pushing the points. So a stretch is pulling, compression's pushing. So for a horizontal stretch that's being pulled away from the y-axis, the x-coordinate is going to change, and you're just going to multiply it by the factor given in the problem. So if the factor was 2, then we're going to take that x-coordinate and multiply it by 2. If it's a vertical stretch, we're going to do the same thing, but we're going to multiply the y by that factor given in the problem. And this works when our factors are greater than 1. It's going to stretch when we're using factors greater than 1. A compression is a push in a horizontal, is when a horizontal compression, we are going to change the x value. So we're going to multiply that factor by our x. And if you notice over here, my inequality looks a little bit different this time. This means that our factor is going to be between 0 and 1. So you're going to have a fraction or a decimal factor for these types of problems. And then a vertical compression is being pushed towards the x-axis, and the y-coordinate is going to change. So we're going to multiply the y-coordinate by our factor given. And again, our factor in that is going to be between 0 and 1 as well. So use the table to perform a horizontal compression of y equals f of x by a factor of 1/2. Use the same coordinate plane as the original function. So let's get some points listed in our table first from our graph. It looks like over -1 and up 3. Looks like we have a point at 0, 0. We have a point at 2, 2. And we have a point at 3, 2 and 4, 2. And let's look a horizontal compression. If I go back here, here's compression. We are going to multiply our factor by our x values. So in this chart, we're going to get some new x values. And our factor is 1/2. So we're going to have to multiply everything by a half. So half of -1 would be -1/2. Half of 0 is going to be 0. Half of 2 is 1. Half of 3 is 1.5. And half of 4 is 2. So now we're going to plot those new points over here on our graph. So -1/2 and then up 3. So -1/2 up 3. 0, 0 is going to stay. Over 1 up 2. 1.5 and up 2. And over 2 up 2. So if I connect those, you can definitely see it's a compression. It's been squeezed together to make a smaller graph there.